All right, so in our previous video, we learned about blood types, but now I want to talk about why understanding blood types are important. We've already talked about how they're going to be important in transfusions, but we want to look at that in more detail. So the reason why we need to know about blood typing is because number one, it can be very important in certain cases with pregnancy, as we will see with RH. And number two, it is important for blood transfusions. Certain blood types are not compatible. If non-compatible blood types are mixed together, the antibodies in the bloodstream can combine with antigens, causing agglutination, and eventually those red blood cells that are agglutinated will burst open, releasing hemoglobin into the bloodstream, and that'll clog the kidneys and cause kidney failure, and it lead to death. It's a problem, so we want to make sure we understand blood typing and its applications. So in order to understand why blood typing and the matching of blood types for transfusion is important, I want to talk a little bit more about those antibodies that we have inside of our blood plasma. So after birth, we begin producing A and B antibodies, right? So just as long as you don't have the A or B antigen, right? So don't forget, I mentioned previously that the antigen A and antigen B are ubiquitous in nature. They're found on the outside of our gut bacteria. They're found, on all different types of food things. We're exposed to A and B antigens right away at the beginning of our life, okay? So exposure to the A and B antigens on things like bacteria will cause our white blood cells to make antibodies, which can attack the A and B antigens on these bacteria. But remember, your white blood cells only make these antibodies if your red blood cells do not have the A and B antigens, right? You don't make antibodies against self-antigens, right? Why? What would happen if you made antibodies against self-antigens? What would happen if you were blood type A and you started to make antibody A? If you said you would destroy your own red blood cells, you're correct, right? So you only make antibodies if you don't have the antigen. So let's look at why this is important. Let's do a case study to understand why this is important, right? So George has antigen B on his red blood cells. We're going to ignore RH for right now to simplify, right? George encounters bacteria with both A and B antigens on the surface, right? So apparently George is a baby, I guess, right? What is George's blood type, right? So let's look at why antibodies are important in terms of transfusions by looking at a case study, okay? So we have this person named George. George has antigen B on the outside of his red blood cells, and George has encountered bacteria with both A and B antigens on the surface. So there's some questions here on the slide. I want you to pause the video and see if you can answer the questions, and then we'll walk through the answers together. So the first question was, what is George's blood type, right? Because George has antigen B on his red blood cells, that means he has blood type B. Number two was, what antigens does George have on his red blood cells? I guess I just answered that. That was antigen B, right? Number three, what antibody or antibodies, if any, does George start to make, and why? George is going to make antibody A, and that's because he encountered that bacterium with the A and B antigens on the surface, and the B antigens weren't problematic because they were self-antigens for George, but the A antigen was non-self, so George started to make antibodies against the A antigen so that he could destroy that bacteria, okay? What antibody or antibodies, if any, does George not make, and why, right? So George is not going to make B antibodies, because if he made B antibodies, those antibodies would attack his own red blood cells. So we still haven't gotten to what these antibodies have to do with blood transfusions, right? So we know certain blood types are not compatible. What makes certain blood types not compatible is the recipient's antibodies. The recipient's antibodies can cause agglutination of donor red blood cells, and that can be problematic because it can clog the kidneys and cause organ failure, like I mentioned, right? So let's look at this case. So apparently George is our blood donor. Okay, George has blood type B, right? Which means that on the outside of his red blood cells is the B antigen, but in his blood plasma is antibody A. Here is the recipient. So this is the person that's receiving George's blood. This person has blood type A, right? Which means they have the A antigen on their surface and the antibody B in their plasma, right? So if you put these cells, these B, or they're not positive, when they positive, these cells with the B antigen inside of the recipient, these antibodies here are going to attack those antigens, right? So the recipient's antibodies will attack those antigens. So that's what we see here. These are the antibodies here at the center, and they're binding to those antigens, causing agglutination of the donor red blood cells. And what's going to happen is eventually these donor red blood cells are going to burst open in the recipient's bloodstream, and now this person is going to have problems with kidney failure and possibly death, right? So this is a bad situation. You might have also noticed we have a problem here, right? The antibodies that are in the donor's blood could also potentially bind to the recipient antigens and also cause those to agglutinate. This is less of an issue because the donor blood volume is going to be so small that there'll be very few of the donor antibodies entering into the recipient. All right, I want to talk about that concept of universal donor and universal recipient, right? So a lot of people say that type O is a universal donor, right? That's because type O red blood cells have no antigens, right? So because they have no antigens, you can give their blood to someone with type A, B, AB, or O. The reason why it's okay to do that is because there are no antigens on type O blood. So even if the recipient did have antibodies in their plasma, there's nothing for them to bind to, right? So really a non-issue. However, don't forget that the donor's blood does contain antibodies. And even though there's just a small amount of them, they can be problematic. So we try not to do this unless we have to, right? So we don't like to use type O blood to give to someone that's A, B, or AB because there is the chance that the antibodies in the donor could react with the recipient. Right? Likewise, type AB blood is said to be the universal recipient, and that's because type AB blood has no antibodies in the plasma, right? And when I say no antibodies, I mean no A or B antibodies. So because they don't have any antibodies, you can give them any blood type and it doesn't matter because there's no antibodies in their plasma to react with any of the red blood cells, so you can't ever get that agglutination. However, don't forget there is the problem that the donor blood does contain antibodies, and those antibodies could possibly react with the AB blood. So like if you were to give type A blood to someone that was AB, right? Don't forget that type A blood will contain B antibodies in the plasma, and those B antibodies could technically bind to and cause agglutination of the red blood cells, the AB red blood cells in that recipient. So again, we try not to use these universal donor and universal recipient ideas unless there's an emergency. We try to type and match as closely as possible. So O goes to O, AB goes to AB, that sort of thing. If you're interested to know about the distribution of blood types in the United States, so it turns out that most people are type O, followed by type A. And then what's nice about this pie chart is it also shows you the fraction of individuals that are positive or negative, right? So O positive and A positive are the two most common types of blood in the United States. And this is actually different in different countries. So yeah, it's kind of interesting. All right, pause the video here and answer these questions. When you're done, hit play and check your answers. Here's a nice little review. We're looking at the results of blood typing cards. See if you can figure out the blood types for these 4 individuals. Go ahead and pause the slide. When you're ready, hit play to see if you got them right. Okay, Maya has blood type A positive because we see agglutination when we add our blood to the anti-A antibody and the anti-RH antibody. So don't forget, agglutination is confirmation of the presence of the antigen, right? The antibody will cause agglutination when the antigen is present. So this is B positive, AB positive, and this is me, O negative. Technically it's Yaz, but it's also me.